G'day and welcome. This is a progress report on the twin fuel pump project, and yes, there has been progress, believe it or not. Details are next. I'm Mark Louth from Black Dog Motorsport, and if you or somebody you know has the black dog chasing them, there are some links in the description which you may find useful. At the end of part 3, I had the first prototype of the control module on the bench, and it wasn't doing diddly squat. Now, I was pretty sure I knew why, and I did to a point, but also I didn't. It was a bit of a saga, frankly. Suffice to say, I had my ambitions and my capabilities well and truly confused, and there were plenty of other mistakes in the design. It just wasn't going to work without a full rethink. So I did the mature thing. I threw a tantrum and stuffed the whole lot in the bin. It was while thinking up a new design that I came across one of these things almost by accident, and I thought, you know what, this might actually do what we want. So while waiting for it to turn up, I designed a small interface board and a wiring diagram for the install of both pumps, and I pre-wired the second pump and tested it. So why don't we have a quick look at those? First off, let's have a look at the interface. The interface allows for both the easy replacement of the internals in case of a failure at the track. I mean, you'd have to have a spare with you, obviously. And it also allows a sensing circuit to link up with the positive of the OEM pump, because our voltage sensing relay module needs to know what that voltage is. There are, however, no additional components added. It is purely an interface and nothing more. This is what the board will look like, and I should have a few of them in the workshop within a couple of days. In order to test the system, I had to wire up the pump, and typically you can't just pop down to your local Subaru dealer and buy the appropriate plug. So I decided to wire in a Deutsche plug instead, because they are water and dust resistant, as well as being pretty tough. As you will see, it wasn't a hard job, but it certainly is time consuming. Frequent testing is also very important as you go along and as you progress through the work, because if you're going to have an issue, you want to find it straight away so you know exactly which joint does not have continuity. One down, only 3 to go, not to mention the Deutsche plug, so I told you it was time consuming. Once I had all 4 wires done, all of different colour, I placed some sheathing over the wires and temporarily secured it with some small zip ties and got ready to fit the plug. Now note, the 4 wires are 2 for the pump and 2 for the level sender, and it should be noted that both sides of the fuel tank have a level sensor fitted, so it's important to reinstate this. And remember, check as you go. You don't want to find problems when you're further along the road, because you will go around and around and down the rabbit hole, and trust me, it'll drive you mental. The back of the plug is numbered, and I placed each wire in the correct place as per the wiring diagram that I had drawn up. So pin 2 on one end of the loom will have the other end of the same wire on pin 2 at the other end of the loom, for example. Note, a quick note on testing. After doing a continuity check and after fitting the plug, I found one of the wires was open circuit. It turned out the crimp was suspect. It tested fine after crimping. The simple act of pushing it into the plug caused it to open circuit. I cannot emphasize enough the importance of checking your work as you go. Right, we're nearing the end now. Now you'll notice that one wire is not in the plug itself. I didn't have a new crimp on hand, so I'll have to fix that tomorrow. Look, the tape I'm wrapping the sheathing in is called Tuff Tape, Tuff, and it's available from Jaycar, #not-sponsored, and it's ideal for this application. It basically fuses itself to itself and it makes an awesome seal. The inside of the plug recess on the top of the pump, I'm going to fill that with hot glue so it doesn't fill up with water and crap, and it's also easily reversible if I need to access the wires later on. So if I use a silicone or something, that would be a bit difficult. Righto, well that's about it. Let's finish up here and let's go put it on the bench and test it. Okay, we've got the fuel pump and the voltage sensitive relay part of the control box on the workbench. I'm just going to run through a quick test. You'll notice I haven't repaired that little issue from yesterday yet, but we'll get to that in a minute. Now the way I've got this set up is I have this power supply here imitating the carb ignition, and this one here will be the output from the OEM fuel pump. Okay, so that'll become a bit clearer as we go on, but anyway, we'll turn the ignition on and our unit will power up. Now it's reading 0 volts, and the reason that it is reading 0 volts is because the engine isn't running and the fuel pump, the OEM fuel pump, is not putting out any current. So we'll just go back, we'll turn that on. Okay, so that 11.4 volts, that's indicating that the car is at idle. As we remember, it was actually less than that, I think, from memory, wasn't it? 9.5 volts or something. And we don't want our secondary fuel pump to run at that voltage because we don't need it. We don't want the pressure being measured, extra pressure being measured by the ECU. And just to confirm, we've got the same there. So we only want this pump to turn on when we're on the track, e.g. under load. So for that, we need about 12 volts. So let's see what happens when we get up in around 12 volts. You can see it's turned on and our pump is running. Now I won't run this too long because it is dry, but now we want it to turn off when we're at idle. Idle is about 9 volts, so anything below about 11.5 volts and the pump turns off. We'll just quickly do that again because there's one important thing I want to show you. Remember that this power supply here is simulating the output from the OEM fuel pump. What you'll notice is there is no current draw. This pump is not drawing any current from the OEM fuel pump, which is exactly what we want. Pump's a bit noisy, but it is running dry. We'll see how it goes in the tank. Righto, that'll do for now. Okay, well, that's it for now. Look, I know it's been a very long time since part 3, but rest assured, part 5, where I wire up the center console with some custom-made wiring looms and switches, is not far away at all. So if you would like to be notified when that video comes out, please consider subscribing. It is free. Hit the notification icon, and as usual, thanks for watching, and I'll see you in the next one. Bye for now.